Good afternoon, class. I hope you're all doing fine. So I created this video because there has been an advice from our internet service provider that there's going to be a service interruption today. So without much further ado, let us begin our discussion. So we shall begin with the checking of assignment. As always, please check your own paper so that you could make some notes on the things you were not able to get. Okay, so let me share my screen. Okay, so you were asked to answer exercise 3.2, page 63, numbers 1B, 1C, 1E, 2B, and 2C. Okay, so let's discuss first 1B. So you will solve graphically the modulus of 2x plus 6 less than 5. Okay, so to do this, first we need to graph y is equal to 5. So let me graph that here. So we have 1, 2, 3, 4, 5. Okay, so let this be our y is equal to 5. So then afterwards, we are going to, we are going to graph y is equal to the modulus of 2x plus 6. Okay, for us to graph this, we need to have the table of values, right? So that is, we have, if x is 0, then y is 6. Okay. And if y is 0, then what is the value of x? So that is negative 3. Okay. Now, since we are looking at the, we need to know the intersection of this modulus with our y is equal to 5. Then let us set y to 5. Then solve for x. Okay. So you can have two values here, right? So if y is equal to 5, then we have 5 can be equal to 2x plus 6. And at the same time, we can also have 5 is equal to the negative of 2x plus 6, right? Because this is a modulus. Okay, so this is 2x, 5 minus 6, or that is negative 1, 2x, or that is x is equal to negative, negative 1/2. Okay. The other value, on the other hand, is we have negative 2x minus 6, or that is 5 plus 6 is equal to negative 2x, or that is 11 is equal to negative 2x, or that is x is equal to negative 11 by 2. And this is also 5. Okay, so let us try to plot this. So we have 0, 6. Okay, so meaning This is where our y-intercept is. Okay. Then we have negative 3, 0. So we have negative 1, negative 2, negative 3. So this is our x-intercept. Okay. Then we have negative 1/2, 5. So this is negative 1/2. This is 5. Okay. And we also have negative 11/2, which is approximately negative 5 and 1/2. So 1, 2, 3, 4, 5, negative 1 and negative 5 and 1/2. So it's over here. So this is our graph. Where's negative 1/2? Okay, at least negative 1/2. Negative 1/2, 5. Okay. So this is now our graph. Okay. And what we are aiming for, we are aiming for that modulus should be less than 5. So what part of the graph is it less than 5? Right? So this is y is equal to 5. So the part of the graph that it is less than 5 is this part. Right? So this is the part of the graph, okay, where our solution lies. Okay, so therefore, our solution set is x is, the value of x here is negative 11/2, right? Okay, that's negative 11/2, and this is the value of x here, on the other hand, is negative 1/2. So therefore, x is greater than or equal to negative 11/2, but less than or equal to negative 1/2. Okay, so if you're able to graph it this way, give yourself 1 point. And if you're able to state the solution, this solution, give yourself 1 point. Okay, and let's go to 1C. Again, we are asked to solve this graphically. The modulus of 3x plus 1 minus 3 is less than or equal to 1. So we need to isolate the modulus at one side. So we will have the modulus of 3x plus 1 is less than or equal to 1 plus 3. Or that is, the modulus of 3x plus 1 is less than or equal to 4. Okay, so to solve this graphically, first, we need to graph y is equal to 4. Okay, so if this is our graph, so this is our x-axis. Okay, and this is our y-axis. So this is y, this is x. So y is equal to 4 is going to be 1, 2, 3, 4. It's going to be here. Okay. So this is y is equal to 4. Then after that, we will graph the modulus of 3x plus 1. Okay. Again, in graphing this, we need the table of values. So in the table of values, let us find first the y-intercept. So that is x is equal to 0. Then what is y? We substitute 0 to x, then y is equal to 1. Okay. So after finding the y-intercept, let us find now the x-intercept. So the x-intercept is the value of y is 0, right? So if y is equal to 0, then the x-intercept is equal to negative 1/3. Okay. Then since we are aiming for the intersection of the modulus to y is equal to 4, then let us plot 4 as value of y. Okay. So again, if y is equal to 4, then we will have 4 is equal to 3x plus 1. And also, can solve for 4 is equal to, negative of 3x plus 1. So we're going to have here 4 minus 1 is equal to 3x, or 3 is equal to 3x, or x is equal to 1. And here we're going to have 4 is equal to negative 3x minus 1, or that is 4 plus 1 is equal to negative 3x, or that is 5 is equal to negative 3x, or that is x is equal to negative 5/3. Okay, so those are our 2 points. We have both our y is equal to 4. One is the x is 1, and the other one is the x is negative 5/3. Okay, so let us now plot the points. So we have 0, 1. And we have negative 1/3, 0. So that is our x-intercept. Okay, then we have 1, 4. So this is 1, 4. Okay. And then we have negative 5/3. Negative 5/3 is negative 1 and 2/3. Then 4. Okay. Okay. So this is our graph. So this is the graph of y is equal to the absolute value, or the modulus of 3x plus 1. So then we are looking for less than or equal. Okay, less than or equal. So therefore, our solution set is, again, the part of the graph that we are interested in is the part of the graph that it is less than or equal to 4. So less than, so that means below the graph of 4. So therefore, we are interested with this part of the graph. Right. Okay. So therefore, our solution set is, what is the value of x here? That is negative 5/3. And the value of x here is 1. Right? So therefore, our solution set is x is greater than or equal to negative 5/3, but less than or equal to 1. Okay, so again, 1 point for the graph and 1 point for the solution set. Okay, then let's go to 1E. 1E, again, we are going to solve this by graphing. So we have the modulus of 3x plus 2 over 2 is less than 4. Okay, but before we graph, we need to isolate first the modulus at one side. So we multiply both sides by 2. So therefore, we have the modulus of 3x plus 2 is less than 8. Okay, so we need to graph y is equal to 8, right? So for example, we have this, and this is my x-axis. Okay. Then, for example, this is our y-axis. Okay, so we need to graph y is equal to 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So this is our y is equal to 8. Okay, then we are going to graph the modulus of 3x plus 2. Okay, so again, to graph this, we need the table of values, right? So we need first, we set first at 0. So if x is 0, then our y-intercept is 2, right? Then we set y to 0. So if y to 0, then our x-intercept is what? Negative 2 by 3. Okay. Now, since we are interested with the intersection of the graph of the modulus and y is equal to 8, then let us set y to 8. Okay. So to do this, we need to substitute y, right? So if y is equal to 8, then we have y is equal to, oops, that should be 8. So that is 8 is equal to 3x plus 2. Then we shall also get the opposite. So we have 8 is equal to negative of 3x plus 2. So we have 8 minus 2 is equal to 3x, or that is 6 is equal to 3x, or x is equal to 2. We have 8 is equal to negative of 3x plus 2, so that is negative 3x minus 2. Then we will have 8 plus 10 is equal to negative 3x, or that is 18 divided by negative 3. Okay. Oh, I'm sorry. Okay. Okay, let's resume. So we have here 8 plus 2 is equal to negative 3x, or that is 10 is equal to negative 3x, or x is equal to negative 10 by 3. So we have two values of x, so we have 2 and negative 10 by 3. Okay, so let us now plot these points. So we have 0, 2. So this is our y-intercept. Then we have negative 2 by 3, 0. So this is our x-intercept. Okay, then we have 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So that is 2, 8. Then the other one is negative 10 by 3. Negative 10 by 3 is negative 3 and 1/3, right? So we have negative 1, negative 2, negative 3, and 1/3. So this is our 8. Okay, so let's now plot the graph. Okay, now we are looking for the part of the graph where it is less than 8. In other words, it lies below the line. y is equal to 8. So again, we are interested with this part of the graph. Okay. So therefore, our solution, okay, what is the value of x here? The value of x here is negative 10 by 3, while the value of x here is positive 2. So therefore, our solution is x is greater than or equal to negative 10 by 3 or less than or equal to 2. Okay, so that is 1E. Okay, now let's go to 2B. 2B, again, you need to solve this graphically. The modulus of 2x minus 7 less than 4 from x is greater than 0 but less than 6. Okay, so again, to do this, we need to graph y is equal to 4. Okay. So this is our x-axis. Okay. And this is, let this be our y-axis. Okay. So y is equal to 4 is 1, 2, 3, 4. So this is where y is equal to 4 is. Okay. So that is y is equal to 4. Okay. Then we are going to graph the modulus of 2x minus 7. Okay. And again, to do this, we need to have the table of values. So if x is 0, y is 7. Then let's set y to 0. Then x is going to be 7 by 2. Okay. All right. Then what else? Okay. Let us now substitute the 4. Okay. Because we want to know the intersection of the line and our curve. Okay. So again, if y is equal to 4, then so we have 4 is equal to 2x minus 7. Then 4 is equal to minus 2x minus 7. Okay. So we have here 11 is equal to 2x. Or x is equal to 11. Oops, sorry. by 2. Okay. While on the other hand, we have here 4 is equal to negative 2x plus 7, or that is 2x is equal to 7 minus 4, or that is x is equal to 3 by 2. Okay. So we have here 3 by 2 and 11 by 2. So you can have it, we can now plot the points. So we have 0 to 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Then we have 7 over 2 is 3 and 1/2, right? Okay, so we have 1, 2, 3, and 1/2. Okay. Then we have 3 over 2, 4. So that is 1 and 1/2. Okay. Then we have 11 by 2 is 5 and 1/2, right? So 1, 2, 3, 4, 5 and 1/2 up to 4. There you go. So connect the dots. All right. So this is now the graph of our modulus of 2x minus 7. Okay. So again, we are looking for the part of the graph that it is less than 4. So again, we are interested in the part of a graph that is below the specified line. Okay. So therefore, our solution is x is greater than, what is the x here? So that is 3 by 2. Okay, x is greater than 3 by 2 but less than 11 by 2. So that is our solution here. So give yourself one check for the graph and one check for your solution. Okay. For 1E, the same thing, one check for the graph and one check for the solution. Okay. Then we have 2C. So we have 0.25 times the modulus of x minus 3 less than or equal to 0.5. So again, we need to isolate the absolute value. So we divide both sides by 0.25. So we will have the modulus of x minus 3 less than or equal to, what's 0.5 divided by 0.25. So that's equal to 2. Okay. By the way, this is from 0 to 6. Okay. So to solve this, we need to graph y is equal to 2, right? Okay, so for example, we have this. Okay, so this is our x-axis. This is our y-axis. So our y is equal to 2 is here, right? So this is y is equal to 2. Then we graph the modulus of x minus 3. So again, we need the table of values. So if x is 0, y is 3. If y is 0, then we have, what is that? Also 3, right? Okay. Then we plug in the value of y. So we have, if y is 2, then we'll have probably 2 points, right? So if y is equal to 2, then we have 2 is equal to the modulus of x minus 3. Okay. Oh, that is no longer modulus. Okay. So if y is equal to 2, then we have, what are we going to do? Then we substitute y to 2. So we have 2 is equal to x minus 3. But there's another one, that is 2 is equal to negative of x minus 3. So we have 2 plus 3 is equal to x. Okay. Or x is equal to 5. The other side is 2 is equal to negative x plus 3. Or we have x is equal to negative 2 plus 3, or that is equal to 1. Okay, so we have 1, 2, and we have 5, 2. So we have 1, 2, and then we have 1, 2, 3, 4, 5. 5, 2. And so we have 1, 2, then we have 1, 2, 3, 4, 5, 2. Right. Okay, then we have 3, 0. 1, 2, 3, 0. Then we have 0, 3. 1, 2, 3. Okay. So this is our graph. So this is the graph of y is equal to the modulus of x minus 3. Okay. And again, we are looking for the values of the graph that it is below the line 2, right? Because less than or equal. So we are interested with this part of the graph. Okay. So meaning our solution is, that is, what's the value of x here? The value of x here is 1. The value of x here is 5. So that is x is greater than or equal to 1, but less than or equal to 5. Okay, so give yourself one check here and give yourself one check here. Okay, so we have a total of 2, 4, 6, 8, and 10. So for this assignment, your total points is 10. Okay, I shall get your score on Thursday. Okay, when we see each other again. Okay, so I hope you were able to get that. Okay, now let us review this is all graphical, right? Your assignment is all about graphical computation of the solution of the inequality, the linear inequality. Okay, so let us review. How are we going to solve this algebraically? Okay, so solving algebraically. Okay, can you still remember? So to solve this algebraically, by definition, it is said that we need to equate. So for example, we have this one. So to solve this graphically, we will have negative 2, okay, less than or equal to x minus 3, but less than or equal to 2. Okay. So let us solve for x. So to solve for x, we need to remove minus 3, right? So we'll have negative 2 plus or minus x minus 32. Then we shall have plus 32 okay, less than or equal to 2. Okay. 32. So to solve for x, we will have negative 2. Okay, we are going to add here 3. So we will also add both sides 3. Okay, let me replace the color so that you will see it immediately. So this is plus 3. So therefore, this is also plus 3. And this is also plus 3. Okay. So we have negative 2 plus 3, that is 1. So this is x. And we have 2 plus 3, so that is equal to 5. Okay. Which is the same of what we have got earlier, graphically. Okay. So let's continue. Remember in our previous example, the given is, so in our previous discussion, okay, the given is the absolute value of ax plus b is less than c. Okay, this time we will be talking about the modulus of ax plus b greater than c. Okay, so let us have an example. For example, we will solve for the modulus of x greater than 3. So we will solve this graphically. So again, to solve this graphically, first we need to graph y is equal to 3, right? So if this is our x-axis, and this is our y-axis, so y is equal to 2 is this line, right? So this is x is equal to 2. Then we are going to graph the modulus of x. So to graph this, we need to produce the table of values. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1, then y is equal to 1, right? Because that is always the absolute value. Okay, let's try to reach, this,